Hi, welcome to this new tutorial. Today I'm going to explain inverse kinematics in detail, and I'm going to put much effort to make sure that you understand it very well. I'd like to introduce my friend who will explain the IK with me.
Hi everyone. I'll start off by explaining the difference between forward kinematics and inverse kinematics. By default, Blender uses the forward kinematics system. Let's try to make a pose like that or bend the arm like that using forward kinematics. So we need to put the hand in front of the character, and I'll show you how it's done with forward kinematics. First you need to select the armature, and go to pose mode to be able to move each bone individually. So this is the hand. If I press G on the keyboard to move it, it will just rotate, it will not move. Pressing G gives the same result as if you're pressing R on the keyboard. That's because this bone is a child of this bone, and this bone is the parent of this bone, so the child inherits the location from its parent. So, if you need to move the child, you need to move the parent first, and then the parent will transfer the movement to the child. So, in forward kinematics system, you need to move the parent bone first. So if you need to bend the whole arm, you will need to rotate or move the most parent bone first, and this will change the location of its child. Also, moving this bone will change the location of its child. Then eventually, you move this last bone. After understanding the forward kinematics, let's try to make a pose that is similar to this pose. I'll select the most parent bone and I'll rotate it around the Z-axis by pressing R, then Z on the keyboard. For the second bone, I'll also press R, then Z to rotate it like that. We achieved the required pose, and we were able to put the hand in front of the character, but we had to rotate two bones, which is something a little bit difficult than moving only one bone. It's twice the work. We have to move the parent bone to be able to change the location of the child bone. The inverse kinematics system can do this more easily. You can directly select the hand bone, which is the child bone, and move it without having to move the parent bones. Inverse kinematics allows the child bone to control the location of its parent bones. The child bone works as if it is a parent bone. Okay, so let's try to achieve the same pose using inverse kinematics. So I'll go back to the rest pose by selecting each bone and pressing Alt-R to reset their rotation. The quickest and easiest option to enable inverse kinematics is to press N on the keyboard to open the N panel, click on Tool tab, and then check the Auto IK option. IK is short for inverse kinematics. This will enable us to quickly switch between forward kinematics and inverse kinematics. Now you can select the hand bone, which is the child bone, press G to move it. As you can see, the child controls the location of the parent bones. You can move the whole arm by moving the hand only. Let's change the viewport, and then grab the hand bone like that to have the required pose. Now I was able to achieve the same thing by moving only one bone, which is a much easier way. So, by using inverse kinematics, I was able to control the two parent bones, the first parent, and the second parent, by moving the child bone. So this hand bone controls the whole arm. The control direction is inverted, that's why it is called inverse kinematics. The Auto IK option is very good if you want to make small adjustments or quick edits or tweaks to your pose, but for long or large projects, you will need something that has more control. The Auto IK option may lead to abnormal arm positions, so you need an inverse kinematics constraint that has full control over the arm. I'm going to reset everything.
The more advanced tool that we will use is the inverse kinematics constraint. This will give you almost full control over the arm. Before I explain the IK constraint for this character, I want to explain it for a simpler armature just to make sure you understand everything very well, then we'll apply what we learn on the character. I think that would be the best method to explain the IK constraint. I'm going to disable the Auto IK option and hide this panel by pressing N. We have a set of bones here. There are 7 bones. For any inverse kinematics system, you need to specify or define two things, the target bone and the tail bone. The target bone is the controller bone. The target bone works as if it's a parent bone, and you can control the locations of a set of bones by changing the location of the target bone. It's like a main bone that controls the location of the other bones. Let's go to pose mode. I want to set this as a controller bone, so when I move this bone I need the chain, or the rest of bones to follow the movement of this controller bone. So this bone will be our target bone. We specified the target bone, which is the first element or component of the inverse kinematics system. The second and final thing that we need to specify or define is the tail bone. The tail bone is the bone that should have the IK constraint. Okay, so the target bone will control all of these bones. This is the first parent, it's the first bone that I created while creating the armature. This bone is a child of this bone. Also, the third bone is the child of the second bone. This bone is the child of this bone and so on. So the last child, in the group of bones that will be controlled, is this bone. The last child is called the tail bone, so I specify or define the last child in the chain as the tail bone, and this is the bone that will have the IK constraint. We found our second and last component of our inverse kinematics system, and now we are ready to use the IK constraint. Keep the tail bone selected. There are two tabs for constraints. The first one is the Object Constraints tab, and it has constraints that can be applied for a whole object. For example, it has copy rotation and limit location constraints. Usually, we use it in object mode. Currently, we are in pose mode because we need to set a constraint for a single bone. The IK constraint can only be set for single bones and cannot be set for an object. We are dealing with individual bones, so you should not go to the Object Constraints tab, you should click on the Bone Constraints tab. This is the tab where you can find the IK constraint, so don't confuse the two tabs. From this menu, click on Inverse Kinematics, and make sure the tail bone is selected. This is the target bone, or the controller bone, so we need to add this bone here. Our tail bone is marked with red color, because we haven't added our target bone yet. Before I add the target bone, I want to explain something. If I press G, the location of the bone will not change. It will just rotate as if I press R. The G and R buttons give the same result. That's because the target bone is parented to this bone, so we cannot change its location. It inherits its location from its parent. You have to move the parent to change the location of the target bone. That's not what we want. The target bone is supposed to move freely because it is a controller bone. We don't want it to inherit its location from this bone. We need to make the target bone separate, so I'll go to Edit mode by pressing Tab. Right-click. Hover over Parent, select Clear. If you choose Clear Parent, the target bone will have no parent at all. If you choose Disconnect Bone, the target bone will still be a child, it'll just be a separate child. A separate child means that if you move its parent, it will still inherit its location from the parent, and it'll change its location according to the movement of its parent. But at the same time, you can change the location of the child alone by selecting it and pressing G. Let's go to pose mode. As you can see, when I press G, the behavior is changed. I can change its location instead of just rotating it. We can also see that this bone is still a child. We can see a black dotted line, which indicates that this bone is a child of this bone. If you move the parent bone, the child bone will move too. What we can learn from this is that the target bone must have two features or characteristics. The first one is that it needs to be a separate bone. The second one is that it must not be a child of any bone, because it is a controller bone, and it works as if it is a parent bone. If you keep it as a child, there will be parenting loop that causes fluttering movements. So let's clear the parenting by going to Edit mode, right-click, hover over Parent, choose Clear Parent. Clearing parent will make it a separate bone, and it will not be a child. I switched to the object mode by mistake, so let's go to the pose mode. This bone is not a child anymore because there is no dotted line here. I'll press Alt-G to reset its location. You can put it anywhere before setting it as the target bone. Once you set it as the target bone, its current position will be the initial position, and any movements away from this position will affect the other bones. Click on the tail bone to be able to see the options of the inverse kinematics constraint. To set this bone as the target bone, choose the name of the armature first. then you choose the name of the bone. If you don't know the name of the bone, select it, and as you can see here it's called bone 7. Click again on the tailbone, and select bone 7. The tailbone now has a yellow color, which means that the inverse kinematics system is ready to work. Now I'll move the target bone. It works very well. It looks like a tail of an animal or something like that. Click on the tailbone again to see the options. Iterations is the number of calculations that Blender does to move the bones. It's something related to programming. More iterations result in more precision in the final location of the bones. Let's try only one iteration, and I'll move the target bone to see the result. As you can see, the other bones didn't have much change in their locations. Let's allow Blender to do more calculations. As we increase the number of calculations, the bones move towards the final expected position. In most cases, I don't think you will need to change this value, so I'll reset it to its default value. The chain length is how many bones you want to control, and you start counting from the tail bone. I'll zoom in. This yellow dotted line gives you an idea about how many bones are controlled by the target bone. As you can see, it touches this point there, and it starts from the tail bone here, so it includes all of these bones. This target bone controls every single bone in the chain. A value of 0 means that you control all of the bones. What if you want to control the tail bone, and the first bone after the tail, and the second bone? So you want to control these 3 bones only. Set the chain length to 3 and this will do the trick. As you can see, the target bone controls only the 3 bones. If you click on the tail, you will see that the yellow dotted line touches the 2 ends of the 3 bones, so it only contains them. What if you don't want to count or include the tail bone? I mean, you set the number of bones to 3, and you don't want to start counting from the tail bone. In this case, you uncheck Use Tail. As you can see, the tail bone is not included among the 3 bones. So this is the first bone, second bone, and the third bone. The yellow dotted line contains them. So if you check that, the tail will be included, and if you uncheck that, the tail will be excluded.
The stretch option allows bones to stretch according to the movement of the target bone. If you check it, you allow bones to stretch, but you need to specify or set the bones that can be stretched. Let's set this bone as a stretchable bone. Click on it and then go to the Bone Properties tab. Scroll down until you see the Inverse Kinematics section, click on it to unfold. For the IK stretch, you can increase it all the way up to a value of 1. Let's move our controller bone, and as you can see, this bone is stretching. It's very useful in case you want to create aliens or a special type of elastic characters. You can stretch more than a bone. Let's select this bone and increase its stretching ability. I'll set the value to almost half so it won't stretch too much. It will not be very elastic. As you can see, it stretches, but not as much as the other bone. No much stretching effect. Click on the tail bone and go to the Bone Constraints tab. If you uncheck the stretch option, it'll be disabled for all the bones. The target bone will not affect the stretching of the bones. You can enable stretch again and it'll work normally. I will reset the stretch of each bone because we are not going to use it. By the way, you can limit the movement of the selected bone. You can lock the IK around an axis, or maybe limit the rotation around the x-axis. For example, let's allow it to move from 0 to 90 degrees only. So for the x-axis, it can rotate here only. As you can see, all the bones rotate freely except for the bone that has the limits, but I don't prefer using these limits because they are related to the inverse kinematics only. I prefer adding separate constraints from the Bone Constraints tab, such as the Limit Rotation constraint. Let's go back to the Constraints tab. The Rotation option allows the bones to inherit the rotation of the target bone. So if you move the target bone, it will work normally. But if you rotate it, the tail bone and the other bones will follow the rotation of the target bone.
For the weight position, it is used if you have more than one inverse kinematics system. I've prepared another armature with two systems. Let's go to the object mode for this armature. I'll unhide the previously prepared system. Let's go to the pose mode. As you can see, there are two yellow bones, which means each one of them is the tail bone of an inverse kinematics system. For the first system, this is the tail bone, and this is the target bone. For the second system, this is the second tail bone, and this is the second target bone. For the first system, we have weight position value of 1. This system has a stronger effect on the other system. That's because the second system has a very small weight position value. So this system will almost have no effect on this system. Here's what I mean. If I move the first target bone, you will notice that the second chain of bones are disconnected from their target bone. Undo by pressing Ctrl Z. If I move the second target bone like that, as you can see, this system couldn't affect this system. So this chain of bones is still connected to their target bone. And this target bone is disconnected because it has lower weight position value. I'll do some random movements so you can observe the behavior of the two systems and the effect of each system on the other. The target bone on the right-hand side has bigger effect than the other controller. That's because we have a very high weight position here and a very low weight position here. Let's hide this armature and go back to our simple armature to explain more inverse kinematics settings.
We all know what the influence does, but I'll explain it quickly. Here is how the armature moves at an influence value of 1. I'd like to increase the chain length to contain all of the bones. Okay, so this is how it moves when the influence is 1. Let's decrease the influence. The effect of the inverse kinematics system will not be very strong. I mean, the target bone will have less effect on the chain of bones. Let's increase the influence again. And this is how the inverse kinematics work. We should now apply what we learned on the character, but I would like to review the features or the characteristics of the target bone or the controller bone. It should be a separate bone to move freely like that. And it should not be parented to this bone or any other bone, because it works as a parent. What would happen if the target bone was parented to another bone? Imagine that the target bone is a child of the tail bone. What would that result in? Let's go to Edit mode and parent the target bone to the tail bone. I'll select the target bone first, then the tail bone to make the target bone a child of the tail bone. We select the child bone first, then the parent bone. Right-click, choose Parent. Choose Make. Let's keep offset to allow the child to move freely. Go to Pose mode. I'll disable the inverse kinematics for a moment to make sure that the target bone is now a child of the tail bone. As you can see, it is a separate bone and it moves freely. And here, we can see a black dotted line which indicates that the target bone has become a child of the tail bone. Now if I move the target bone, it'll try to move the tail bone because the target bone works as a controller bone or as if it is a parent bone. The target bone will try to move its parent. And if I move this parent bone, it will move the child. So the target bone moves as I move the tail bone because we already set the tail bone to be the parent of the target bone. So when you move the parent, the child will follow the movement. So moving this bone will give a movement to this bone. Because this is the target or the controller bone, it changes the location of this bone as it moves. And when this bone moves, it'll move this bone too. So they control each other, and this effect is called a parenting loop. This is not good because it causes fluttering in the animation. I'll press Alt-G to reset the location. I just put the target bone back to its original position, but it is still a child of the tail bone. I'll enable Inverse Kinematics. Now the target bone works as a child and a parent at the same time, which will cause errors in the animation. As you can see, it doesn't work well. The target bone and the tail bones are trying to affect and inherit the locations of each other. Do you remember what would happen if the target bone is connected to the other bones? Let's do it. As you can see, it won't move because it is connected to the tail bone. It just rotates. The target bone needs to be a separate bone to be able to control the rest of the bones. After clearing the parenting of the target bone, it works well now.
The last thing I would like to explain in inverse kinematics is the pole target bone. This is very useful to have normal bone poses and movements. The pole target bone controls the pole rotation. For each bone, if you draw an axis that connects between its tail point and its head point, the pole target bone will control the rotation around this axis. So the pole target bone controls the rotation of the bones like that. Why is this important? In case of a character, you will use this a lot to make the elbows and the knees bend in natural or normal positions. It'll help the arms and legs to have natural poses. It will prevent some mistakes in the animation. I explained the basic function of the pole target bone, but I'll explain it in detail while applying this to a character. Let's apply what I explained on this simple armature first. I'll move the bones to take this shape. I'll go to Edit mode. And I'll duplicate my target bone by pressing Shift-D. Instead of duplicating or copying, you can create a new bone by extruding. It doesn't matter how you create the new bone, we just need a new bone to be our pole target bone. I would like it to have an initial location like that. The pole target bone controls rotation only, so I prefer to have an initial position that is a little bit far from the armature to be able to move it around the armature. Of course, this bone should not be a child bone because it is also a controller bone, and it controls the rotation of the chain. The pole target bone will control the rotation of each bone around its axis like that. Let's call this bone pole. And let's select the tail bone. Oh my god, it's hard to select. Let's go back to the Bone Constraint tab. Select the name of the armature first, then select the name of your pole target bone. Let's see what will happen when I move the pole target bone. As you can see, it affects the rotation of the bones like that. The x-axis of each bone is pointing towards the left direction, and as I move the pole bone, the bones of the chain rotate. For this exact position of the pole target bone, what if you want the z-axis of each bone to point towards the pole target bone? How can we do this? Let's select this bone. You can do this by changing the pole angle, so I'll increase it, and the bones will rotate as I increase the value. Now the z-axis of each bone is pointing towards the pole target bone. You can move this anywhere, and the bones will keep the z-axis pointing towards the pole target bone. So the pole angle is used for calibration. It sets the initial rotation for the current position of the pole target bone, so it calibrates the rotation of the bones. Of course, you can also change the value anytime. Now I'll explain how can this be useful in case of a character. I quickly set up an inverse kinematics for this arm. This is our target, or controller bone. It moves the arm like that. This is our pole target bone. This is the chain of bones that is controlled by this target bone. I'll reset the location of the target bone to reset the pose of the arm. Now I'll move the target bone along the x-axis, and I'll grab it towards the character. Of course the arm will bend, but how did Blender know the correct way of bending the arm? I mean, there are many ways to bend these two bones. Blender can bend them like that. Or maybe like that. It can bend like that too, so it can move in a circle. There are unlimited directions or ways of bending. Imagine that this bone controls the rotation of those two bones around their axis. This will result in controlling what the elbow is pointing at. So, controlling the rotation of the two bones will control the bending of the elbow. That's why it's very useful to use a pole target bone for each elbow and knee, so you can make the knees and elbows point at the pole target bone. Then you put the pole target bone in the correct position. I have a note to say, the arm may be stiff and doesn't bend after setting the pole target bone. If this issue happened with you, select this joint and move it a little bit towards the pole target bone to prevent any stiffness of the arm. This way you will also help Blender to know the correct bending of the arm, because this will be the easiest or the shortest path to bend the arm. It's already working well. Also remember that you can calibrate or adjust the position of the pole target bone with the rotation of the bones. Maybe you want the pole target bone to be up a little bit like that, so click on the tail bone and make some little adjustments to the pole angle. So, you can control how the armature bends, or the bending direction of the elbow, for this current position, or current location of the pole target bone. Some people like to put the pole target bone in front of the armature. Okay, so I'll press G to grab the bone and put it here. It's up for everyone how they organize the bones, so maybe you feel like it's better to put the pole target bones in front of your character. This will result in wrong elbow bending. How can we fix this? If I rotate this bone, nothing happens. So if I make this bone rotate 180 degrees around the x-axis, this will have no effect, so we fix this by calibrating. So go to the pole angle and type in 180 degrees, and this will reverse the pointing of the elbow for this current position of the pole target bone. So this is how the pole target bone works, and for me it's very useful.
Let's continue playing with our simple armature, and this time we need to control fewer bones. This is the pole target that I've just explained. I'm going to delete it, so let's go to edit mode and the whole armature will be in its rest position. I'll delete the pole target bone because it's no longer needed. Let's go back to the pose mode. As you can see, the inverse kinematics system doesn't work because we deleted the pole target bone, so we need to remove or clear the name of the armature from the field of the pole target bone to be able to use the system normally. If you keep the name of the armature here, this means that Blender will wait for you to add the pole target bone and the system will not work. What if you don't want to control the first three bones? What if there is no need to move them with the target bone, you just want to control the last three bones only? If you try to change the chain length, it will not work because it counts starting from the tail bone. So what if you want to control these three bones only? It seems that we need to change our tail bone because we want to control a different whole chain or set of bones. So I'll delete the current inverse kinematics system and create a new one for the new chain of bones. I'll just put this back in its position by pressing Alt-G to clear its location. For this new set of bones, do you remember how to specify the two main components to build an inverse kinematics system? We need to specify the target and the tail bones. For the target bone, I'll choose the old one, but I'll change its initial position. I don't want it to be very far from the 3 bones, I need it to be somewhere around here to make it easier to control, so I want it to almost touch the 3 bones. So I'll move it along the z-axis, and I'll rotate it 90 degrees around the y-axis to be able to easily select it. It doesn't have to really touch the 3 bones, so we can move it a little bit along the x-axis. The initial position is up to you, and this is the initial position that I want. The second component is to specify the tail bone. I want the target bone to control this chain. This is the base bone, I call it the most parent bone. This is the first bone that I created while creating the armature. This bone is a child of this bone, and this bone is a child of this. So this is the last child bone in our set of bones. This is the smallest child, so this will be our tail bone. These bones are also children, but we don't want to control them. We don't want to include them in our inverse kinematics system. This is the last bone in our set of bones that we want to control. These bones should not be affected, so this bone must be our tail bone. We add the inverse kinematics system to the tail bone, so let's add it. Let's add the IK system. For our target bone, let's see the name of this bone by selecting it and looking at this area. It's called bone 7. Select the tail bone again, choose the name of the armature, then the name of the target bone. Before selecting the target bone, make sure that this is the initial position that you want, because if you move the target bone after selecting it or setting it, the whole chain of bones will move with it. So you set the position of the target bone first, then you add it to the inverse kinematics system. This is our target bone. We can move it like that to control these 3 bones only. The other 3 bones are not affected by the movements of the target bone, they just move because they are children of the tail bone, so they inherit their movements from the tail bone. If you do clear parent, they will not move with the tail bone. You can use any option normally like we did before, and you can also set a pole target bone. So for any IK system we need a target bone that controls the rest of the bones, and we need to specify the tail bone and add the inverse kinematics to it.
Let's apply what we've learned on the armature. Let's go to the pose mode. I already set up inverse kinematics for this arm, so I'll show you how to set it up for the other arm. Where is the target bone? What is the bone that should take control of the arm? We need the whole arm to follow the movements of the hand, so it seems that the hand should be the controller, or the target bone. After specifying the target bone, we need to specify the tail bone, and to be able to do that, let's see the chain of bones, or the set of bones that we want to control. We need this bone to control those 2 bones, because the 2 bones to form the arm of the mesh, so our chain of bones consists of 2 bones only. In our chain, this is the parent bone, and this is the child bone. This bone is a child of this bone. So in our chain, the last bone, or the most childish bone, is this bone, so it will be our tail bone. We should add the inverse kinematics constraint to this bone. Okay, let's add it. For the target bone we should select our hand, but we have a small issue here. The target bone should be a separate bone, and it shouldn't be a child bone. The hand bone is a child of this bone, so it can't be the target bone. It's also connected to its parent, so when I press G, it'll just rotate, and I won't be able to move it to control the whole arm. So I'll disconnect the hand bone from its parent. I'll go to Edit mode. Right-click. Choose Parent, then Clear Parent, and Disconnect Bone. As you can see, it's disconnected. From this black dotted line here, we know it is still a child of this bone, which is not good, because the target bone must not be a child. It controls the bones as if it is a parent, and making it a child will cause errors in the animation. Even if it is a disconnected bone, it must not be a child. I'll press Alt-G to reset its location. It is still a disconnected bone. I just put it back in its original location. In addition to the errors that will occur in the animation, because the hand bone is a child, disconnecting the hand is not a good idea because it will cause the arm to stretch. So this is the worst condition for the inverse kinematics system, but I'll try it with you anyway. I'll go to pose mode to set your target bone. What's the name of this bone? I think we should rename it to have an easier name. I'll just name it hand. Let's go back and set it as a target bone. I'll try to move the hand. Surprise, the whole armature moves because the chain length is set to 0 by default and it includes all the bones in the armature. What is the correct number of bones? This is our target bone, so it is not counted at all. Our chain contains only 2 bones. So I'll type 2, and the tail bone is included. We start counting from the tail bone. The tail bone is bone number 1, and the other bone is bone number 2. Let's try to move it again. As you can see, there are too many errors in the animation. The errors in the animation are because the hand, or the target bone, is a child of the tail bone. The hand bone will try to control and move this bone because it is the target, or the controller bone. This bone is also the parent of this bone, so when it moves, it will change the location of its child. The hand is like a parent and a child at the same time. The 2 bones inherit the movements and give movements to each other. They are trying to control each other. It's called a parenting loop. That's the cause of the errors in the animation. Also, it's a bad idea to disconnect the hand bone, because if you press G then X to move it along the X-axis, it will stretch, and no one can do this unless they have a superpower. Most people don't have superpowers, so it might not be a good idea to disconnect the hand bone. So we need to keep the hand bone connected, and we need it to be a child of the tail bone. I'll go to edit mode and connect it to the tail bone again. Now if you try to move it, it will just rotate to prevent any stretches. So where is our target or controller bone? How can we specify it? It seems that we cannot use the hand bone as a target bone. The solution is to make a copy of the hand bone. I'll not set the hand bone as a target bone. Then I'll go to edit mode and make a copy of it. The new copy will be our target bone. It is a disconnected bone, but it is still a child. I know that from the black dotted line, and I'll clear the parent. Some people like to put it in place of the original hand bone like that. They make it larger to easily select it. They may hide the hand bone as well. Something like that would work. Others like to rotate it 90 degrees like that, or maybe like that. The initial location or rotation is up to you. You choose any of these positions and use it. For me, the best initial location could be this, because you can use a copy rotation constraint, and use this bone completely as a hand bone. I'll explain this idea in detail later. The inverse kinematics system lets this bone control those 2 bones, but the target bone will not give any rotation to the hand bone. If you need the target bone to have a control over the rotation of the hand bone as well, you will need to add the copy rotation constraint. It is a separate constraint, so it is not a part of the inverse kinematics system. It's something additional that we use with inverse kinematics to allow the target bone to have full control over the arm and the hand. So let's select the copy rotation constraint. For the target bone, let's see its name. I think we should rename it. I'll call it New Controller. Select the original hand bone. Go back to the Bone Constraints tab. Now select the target bone. It's called New Controller. You can also set the rotation type to local space. Now when I rotate the target bone, the hand bone will rotate with it, or inherit its rotation. It seems that the direction of rotation is inverted, so you can click the hand bone, invert the axes you want. I'll invert all of them. Now it rotates correctly. By using the copy rotation constraint with the inverse kinematics constraint, you control everything by moving and rotating the target bone. Then, the hand bone will not be needed at all, and you can hide it. And I want to confirm that the copy rotation constraint has nothing to do with the inverse kinematics constraint, it is just a completely separate constraint. Let's go to the inverse kinematics constraint. I'll set the target bone. Now you can move the target bone freely without any errors in the animation. I'm moving it in many directions, and for a long time to prove that there is no fluttering. You can also rotate it, and the copy rotation constraint will work, and the hand will inherit the rotation. If the rotation is not working very well, you can invert some different axes and try again. If I press G, then X, to bend the arm, it will work properly. But if I grab the target bone in some random directions, the arm may bend in the wrong direction, making some abnormal poses. To prevent the elbow from bending or pointing at random directions, we need to create our pole target bone. I'll go to Edit mode. To create a new bone, you can just copy your target bone. Move it here. Rotate it 90 degrees. You can put it in front of the armature or behind it. The rotation doesn't really matter, but I'll just make a small edit like that, so this is the initial position that I want for the bone. I would like to rename the bone. I'll call it pole.L. It's a good idea to leave .L or .R at the end of the bone's names to make it easier to symmetrize your armature and do things like that during the rigging process. .L refers to the left bones, and .R refers to the right bones. Let's set our pole target bone. The pole target bone controls the rotation of those two bones. The resultant is that it will control how the elbow bends and what it points at. We need to play a little with the pole angle, because there is a mistake here, so you can calibrate the rotation by changing the pole angle. I think negative 180 degrees is the most suitable value. Let's test it. There is stiffness in the arm doesn't bend. So we need to move this joint a little bit towards the pole target bone. Go to Edit mode and move it just a little bit. Let's test it again. Wow, it works properly. It is fully controllable. There is an issue that didn't happen with me, so I was lucky during this tutorial, but it may happen with you. If some artifacts happen in the mesh object of the character, as you move any target or pole target bone, this means that you need to set which bones have the ability to deform your mesh. So how can we remove the deform feature from the bones? Keep your controller bone selected. Go to this tab. Scroll down until you see this deform section. Make sure that the deform is unchecked for each controller or target bone. For example, this pole target bone doesn't need to have that deform feature, because it's just used for controlling the other bones. It doesn't deform the mesh. For the other arm, we need to uncheck the deform from the target bone. Also for the pole target bone, we need to uncheck deform as well. For a bone like that, it affects the upper arm of the mesh, so it makes deformations or changes to the upper arm, so we need to keep the deform checked for this bone. Controller bones are not meant to change your mesh, they aren't supposed to cause any deformations, or there will be some artifacts, so make sure you uncheck deform for all of your controller or target bones. A piece of advice that I would like to tell you in this tutorial is that you need to use limit rotation constraint for the bones of the arms and the legs. You may think that the inverse kinematics system is enough, and it's able to calculate proper or normal body movements with the help of the pole target bone. But Blender automatically calculates the movements of the chain of bones according to the movements of the target bone. Since any automatic process can have some issues, we need to add some extra safeguard or extra lock for the bones to help Blender calculate the normal or proper body positions. In some cases, you may need to temporarily disable the inverse kinematics system to make small tweaks or adjustments so the limit rotation constraints will help you set more natural poses quickly. I'll disable the inverse kinematics system, and then I'll press R, then Z, to rotate the arm. As you can see, it can make abnormal poses. It's okay for the arm to bend like that, but this pose is abnormal. There are two ways to limit the rotation of the bones. The first method is to do it using the inverse kinematics properties by going to this tab. Scroll down. And here you will be able to limit the rotation of the selected bone. But if you want to disable inverse kinematics for any reason, this will be disabled as well, and the rotation of the bones will not be limited anymore. I prefer to use a separate limit rotation constraint for each bone. For me, it's better to add an extra limit rotation constraint from this menu. If you scroll down, you will see the limit rotation constraint. I'll fold both of the constraints to control them easier. We need to put the limit rotation constraint before or above the inverse kinematics system, so you limit the rotation of the bones first, and then the inverse kinematics system will allow the bone to move within the allowed range. I'll keep the inverse kinematics system disabled to see the effect of the limit rotation constraint only. Let's open the N panel. I'll clear the rotation of this bone. For the rotation around the Z-axis, we need to specify the minimum and maximum rotation values that this bone can have. I think this bone can go back a little. I think a value of 11 is good, and it cannot go beyond that. And for this pose, we need to look closely at the mesh to see the most suitable value. We want to make sure that there are no artifacts, so I think -127 is the most suitable minimum value. So we need to limit the rotation of the bone starting from -127 degrees to +11 degrees. It should move within this range only. Okay, so let's enable limiting the Z-axis here, for the minimum value type -127, and for the maximum value type 11. We did that for the local space of the bone, so don't forget to set it. Now let's test it, and no matter how you rotate your bone, it will not exceed your allowed range, and there will be no abnormal poses. As you can see, I'm trying to test it again, and I move my mouse to some far locations, and it works very well. If you look at the rotation value, it's 200 something, but the bone doesn't exceed our minimum and maximum values. I'll clear rotation by pressing Alt-R. You should do the same steps with the Y-axis. This is a normal pose, but the arm is not allowed to move like that, so you need to read the maximum and minimum values from here and put them here. You do the same thing for all the axes. You also need to do the same thing for this bone and for the hand bone. So you should use the limit rotation constraint for all the bones in the arms and the legs, and limit the rotation around all the necessary axes. And this way you will have a strongly rigged armature that doesn't cause any errors or mistakes in the animation.
I'll hide those two bones. If the elbow is very thin while bending the arm, then you need to allow the armature to keep volume. Select your mesh, go to the Modifiers tab, check Preserve Volume, and your mesh will not lose any volume. As you can see, it makes a difference and this looks much better. How about setting up an inverse kinematics system for the leg? Of course, we need the foot bone to control the leg by controlling these two bones. So it seems that it should be our target bone, but at the same time we need it to be a connected bone to prevent stretching. So the target bone will be a copy of the foot bone, or it will be a new bone that is located near the foot bone. It's a similar process to what we did to the hand bone. Instead of copying or duplicating the foot bone, I'll select this joint and press E to extrude a new bone. After pressing E, I press Y to extrude it in the direction of the Y-axis. This will be my controller or target bone. I'll right-click and clear parent to make sure that it is a separate bone, and it is not a child. As you can see, it moves freely, and there is no black dotted line here. Press Alt-G to reset its location. This will control the chain that consists of these two bones. This is the parent bone. And this is the child bone, so I'll add the inverse kinematics constraint to this bone. The target bone is our controller bone, so I'll rename it to make it easier to select it. I'll call it leg.L. Then I'll go back and add it. If I move the controller bone, the whole body will move because I haven't set the number of bones or the chain length yet. We need to control this bone, and this bone, so we have 2 bones only. So I'll set the chain length to 2. It works very well, but we don't have the right or the natural bendings of the knee. With the help of the pole target bone and the limit rotation constraints, we will be able to achieve normal knee bendings. I'll press Alt-G to reset the location of the target bone. Then I'll go to edit mode to add the pole target bone. I'll click on this joint and then press E to extrude a bone. Don't forget to clear parent. We move it a little bit far from the knee, because it controls the rotation of the 2 bones. It'll be easier to control if the initial location is a little bit far from the knee. I'll do it in the pose mode. This is where I want the pole target bone to be. I'll rename it. I'll call it pole leg.L. Let's add it as a pole target bone. Well, it seems that the initial rotation of the bones is incorrect. They have wrong rotation values. It seems that we need to calibrate it. Let's try some random values. I think -90 degrees is the most suitable value. Let's move it. It works better now. I think it will work better and better if you set the limit rotation constraint for this bone, and the foot bone, so you need to click this bone and add the constraint from here. You do the same steps for the other bones as well.
I hope you enjoyed this tutorial, and of course this is a long tutorial, so it could be better if you divide it into parts and watch 1 part per day. If you have time, you can repeat it as many times as you want. Don't forget to subscribe to get more tutorials like this. Good luck, enjoy your time, and have fun learning Blender.